how to clean up and machine gunmetal castings. Working with gunmetal castings is quite different to using cast iron components. Making accurately finished parts can be difficult. This video shows 2 examples of how I do it. There are of course other methods that can be used to obtain the same result. This video is a spin-off from how to build a Blackgate Sweet Pea locomotive. This is a rebuild and one of the motion brackets was missing, so I bought a casting from Blackgate's Engineering, sawed it in half, and I'm about to show the main process for making a carbon copy of the part I already had. I placed the original component on the casting and drew round it with a felt tip pen. The felt tip pen line is only a guide. What I'm about to do is clean out this part of the casting. This particular shape is very important. Here is a health and safety warning. When using filing, grinding or sanding equipment, always wear a breathing mask, and in the case of filing, sanding or grinding any metal that has been cast using sand, I also recommend wearing a pair of goggles in order to protect your eyes from the metal particles and sand residue. Even a small filing job like this is not only filing the metal, it's also filing sand particles, and the combination of the gunmetal, which soon turns green in contact with your skin, particularly when it's hot and you're doing physical work, which of course makes you perspire. The metal particles and sand particles stick to the perspiration. For instance, the front part of my upper body has turned green, and my eyes have been uncomfortable now for a couple of days since I did this job. I cleaned up this casting using a combination of methods: filing, sanding and grinding, all of which contributed to parts of my upper body looking a bit like Kermit the Frog. Once I'd fettled the castings to make them workable, I clamped both of the parts back to back in my milling machine, and here, using a small milling cutter, I'm levelling off the new casting to match the original one. Why am I using such a small milling cutter? Well, to be perfectly honest, that was what was in the collet. I could have used a face cutter and done this in one operation, but I chose to do it this way, and it looks quite good once it's finished. When the component is finished and bolted in place, you'll never see this side of it. The original part has 3 holes in it, and these are the holes that allow you to bolt it to the frames at each side. You will notice that the holes are not even, but I'm following them exactly as I see them here, because originally when the main frames were drilled, they will have been clamped together, so all of the holes will have the same spacings on each of the components. That's the plan anyway. Here I'm drilling the holes in the new casting. For the first hole I used a centre drill, but for the other 2 holes I just used a twist drill straight away. If you're a beginner to this sort of thing, I strongly recommend using a centre drill. I'm not a beginner, and it's actually quite easy to persuade a normal drill bit to drill a hole precisely in the right place on just a mark on the metal. But this only works really because the gunmetal is very soft, so the drill can actually mark its way through as it's drilling. This principle works with cast iron too, but it's not so good on steel or any harder metals, because the twist drill will wander about and suddenly you find the hole is not where you wanted it in the first place. If you practice the process on bits of scrap metal, you will soon become aware of what I'm talking about. Hole number 3 and everything's looking good. You will see how well it fits the holes in the frames if you watch the next episode of how to build a Blackgate Sweet Pea locomotive. A bit of a diversion. These are the crosshead guides and they're actually incorrect. I'm going to Blackgate's Engineering on Thursday, so I will buy some more 3/8 square bar, as well as some other things that I need. In this clip, the crosshead guide bars do look okay, but I'm holding it in such a position that it is in the right place. In reality, it's a bit short. After a bit more work, these parts look okay. The one on the left is the original and the one on the right is the one I'm making. The next gunmetal part to process is the reverser stand. This supports the reversing lever, which in the design of this type of valve gear has to be very strong. This is where it fits, and I need to both clean this up and machine it accurately. The first thing to do is to clean out the hole in the casting. I'm cleaning up the hole in the casting at this point using a hole cutter in my electric drill, and I must say that I don't recommend doing it this way because if the drill bit grabs in the hole, it will throw the part about. But gunmetal's a very soft metal, so it's not doing that. And besides, I'm being very gentle with it. It's looking much better than it did 5 minutes ago. This is a small but important part of the job from an appearance point of view. Health and safety, always remove the chippings from the bench, because if you don't do that, they will stick in your hand. Now, on a relatively clean bench, I can plan the next part of the operation. I'm going to take this component into the outer part of the workshop and use the 4-inch belt sander just to clean it up a bit. I'm not going to show that, though. I will leave it to your imagination. For this job, this is an essential tool. It's a set square. Both the bolting face to the frames and the larger part that supports the reversing lever need to be at 90 degrees to each other, not 87 degrees and not 94 degrees, a perfect 90 degrees. This is not difficult though. I set it in the machine vise by eye and took a cut across the top. And this is okay, but it's not good practice, definitely not good engineering practice. My calibrated eye works quite well after so many years. And as you can see, I'm removing sufficient metal to get through all the rough stuff and leave a completely flat surface on the top. Once I'd done that, I lowered the milling cutter and took a cut all the way around. This eventually gave me very clean edges. I don't need to bother too much about the corners, they will be rounded. For this to be at a perfect 90 degrees to the main top plate, I need a datum surface, and this is it I'm making at the moment. That's looking good. Now I turn the part around in the machine vise with the larger flat surface uppermost. This needs to be exactly at 90 degrees to the part that I've just machined, and I checked that using a set square down onto the milling table, and once I was happy that it was at 90 degrees, I could continue the cutting process. I'm going around the edges first. The part isn't particularly flat, but the underside in this area is really unimportant. What is very important is that the top face needs to be at 90 degrees to the part that you've just seen me machine. Most of the time I'm using the milling cutter against the work, turning towards it, but occasionally I go the other way. It doesn't really matter too much on gunmetal because it's very soft stuff. I'm using an end mill for this job. It's not a slot drill, it has more cutting surfaces and therefore is not as violent as using a slot drill, which only has 2 cutting surfaces. And also that's why I'm using this small milling cutter. If I did use a larger cutter, particularly a slot drill, this component could be easily ruined. Don't forget it's only a gunmetal casting and it's clamped into the machine vise by quite a thin part of the casting. I'm brushing away the chippings frequently. If I didn't do that, you wouldn't be able to see what the cutter was doing. I don't know why, but there's something satisfying about using a small end mill on a piece like this. All the lines look like the lines on a nice grass lawn. But not green. The only bit that's green is the mid part of my upper body, because the particles were fine enough to go through my t-shirt. I'm being serious about this warning. When grinding or sanding gunmetal castings or any sand castings, you do need to make sure that you're wearing the correct type of PPE, personal protective equipment. That's it for this episode. When I hold the gunmetal reverser bracket in place, it is a perfect 90 degrees between the bench and the chassis. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.